Redmond High School Pre-Calculus presents Dan the Demolisher and the Crane Catastrophe story to show a simple harmonic motion. One fine day in spring, Dan was at work operating his crane. However, there was a slight malfunction which required Dan to walk down to the end of the crane. While you and I may not see this as a good idea, Dan, on the other hand, ain't afraid of nothing. Unfortunately for Dan, the crane was especially slippery that day as it had been lubricated the night before. A strong breeze caused Dan to stumble off of the crane to his near death. He landed on his feet on the wrecking ball. Fortunately for Dan, he was born with cat-like reflexes and some crazy orange hair. The strong breeze turned into Hurricane LaFonda and began to swing the ball. But what he didn't realize was that the swinging motion was actually a harmonic motion. But before we do that, let's break it down. Harmonic motion is represented by if the distance d from the origin at time t is given by either d equals a sine wt or d equals a cosine wt. In order to graph this harmonic motion, you will need to know that amplitude is the maximum displacement from the equilibrium, which in this case is 10 feet, because Dan swings 10 feet in one direction. You'll also need to know the period, which will be the time it takes for one cycle. It takes Dan 40 seconds to swing back and forth until he reaches his initial position. Now, we have W, which will convert period into terms of pi. Next, the equation of motion is given by combining all of these pieces of information and receiving d equals 10 sine pi over 20t. And finally, we have frequency, which is cycles per second, and given by w over 2 pi. Therefore, our frequency is 1 over 40 cycles per second. To create this graph, draw a point at 0, 0 to represent the wrecking ball, its equilibrium. Next, find the distance the wrecking ball swings in intervals of 10 seconds. We find that after 10 seconds, the ball reaches a maximum of 10 feet from equilibrium. 10 seconds later, it was back at equilibrium. 10 seconds back after that, the ball swings 10 feet in the other direction. Because this is a sinusoidal motion, it can be assumed that this graph continues in this pattern. Harmonic motion can really be used to record and graph any type of motion that oscillates back and forth from an equilibrium at equal distances. And you can always find the equation as long as you are able to find the amplitude, period, and frequency. As for Dan, if only he had known his sinusoidal motion repeats itself over and over again, he wouldn't have been so reckless with his harmonic motion. For all we know, he could be still swinging to this very day.